Welcome to the second part of my course on linked data event streams. This part is about specification and it's going to be a little bit more technical. So what you should already know before starting this part of the course is 1, what linked data and RDF are, 2, the vision behind linked data, event streams and the priority shield, which were both part of my first presentation, and then 3, how to read Turtle and JSON-LD. If you don't know that last part, you'll find it online. There's a JSON-LD playground, which is pretty explanatory, and Turtle is a pretty simple serialization of RDF data. So we've seen the priority shield for data publishing, and what we are now going to focus on is the core part. How do we model this part of the priorities? What kind of web API will be built for that? And in this image that we already showed last time as well, it's of course first the event stream part itself that we're going to show. It's part of the specification that you can also find online. The link is also in this below in the text, w3id.org/LDES/specification. Read through it. Everything that's in it is also going to be part of the rest of this presentation. Prefixes used throughout this presentation, also important to know that we're working with linked data, so you can so everything that we use are URIs that actually exist, of course, except for the example.org URL that's in here. So first of all, the definition of a linked data event stream. Well, it is a collection of immutable objects. I think that's a really important thing to understand, that if you have a collection of things, well, all these things that were at one point part of the linked data event stream, they're never going to change anymore, and they're always going to be part of the linked data event stream. So the implication of that is that a linked data event stream always grows. But the benefit of that also is that when a consumer once processed a member, it never has to process it again, because a consumer can understand that object is never going to be change again. You can also see it as an inheritance or like a subclass of the tree collection concept, the tree specification, on which we will come back later on in this presentation. Simple example. For example, for sensor observations, you could say that we have a collection that is of type LDES event stream. It has a member, so we use the tree specification over here to say that we have a member, and that member, there's one member over here defined in this example. It's observation 1. And observation 1 is an observation, has a result time, and has a simple result, which we have omitted over here for simplicity reasons. But if you add one, you just add one to the collection, and so on and so forth. Now, for street names, this becomes a little bit more complex, because, for example, you could say, I have a collection of street names. For example, street name 1 is Station Road. But what if at some point Station Road changes and it becomes Station Square? Then you cannot just add this triple to the collection, because it collides. Right now in RDF semantics, it would say that street name 1 has 2 labels, Station Road and Station Square. That's a problem. So what we do in order to make the street name 1 as an object, to make that immutable, is to introduce version identifiers. So we say tree member, there's a street name 1 version 1, and then there's also street name 1 version 2. And they both have different labels. And now we need to understand that v2 is a later version. We cannot just parse the URI to understand that that's v2. We just need to understand that that was created at a later stage, and that they're both a version of the same object. And that's what we do with, for example, DC terms. It's the linked data event stream specification doesn't say how you need to do it, but DC terms is a good way of doing it in each case. So saying that you have DC terms created at a certain timestamp, and that you have a DC terms is version of street name 1, and you also add this to the second version. This way, a client can understand that version 2 is the later version of that street name, and that Station Road was applicable in 2020, but starting 2021, that you'll have to use Station Square for that road. Good. What's a data set then? Because of course now we have one collection or one linked data event stream, But what do you call a data set? And I like the concept of a data set when we are talking about organizational constructs such as an address registry or a sensor network or a public transit timetable. And all these things can be described using, that's a vocabulary within linked data to describe data catalogs, DCAT, it's a W3C standard. We can describe it using that vocabulary. So it defines a data set, a catalog, a distribution, a data service, and so on. But a DCAT dataset, such as an address registry, you could see it as a combination of multiple event streams. For example, an event stream of street names, an event stream of post info, so the post codes, the zip codes, the municipalities, and the address objects themselves, so the numbers in the road. We've also developed that. You'll see later in section 3 of the course. You will also see a video by Dwight van Lanker that actually implemented exactly this for Flanders. So you'll also be able to see this as part of a DCAT catalog. Now, a sensor data platform, exactly the same idea. You can just implement it as multiple event streams. One for the sensor objects, like if you add sensors to your network, you'll add it at the end of that sensor linked data event stream. And for the observations itself, so all the observations made by all the sensors, you can also put them in one collection. Or maybe you can decide to say, oh, I'm going to put all the observations per sensor in a separate linked data event stream. It's up to you how you design your information architecture, how you design your data sets. A dataset is just a collection of multiple event streams. Same story for public transport timetables. You can also say, like, we have the stations or the stops of our timetables. We have departures and arrivals. We have the trips, so the specific vehicles that pass by the stops. And we also have the routes they follow. And we also already have that in production, combined in a DCAT catalog at graph.irl.be/sncb/catalog. So, but if we have one big catalog, a data catalog full of metadata, and we have and we want to understand what data these data sets contain, we actually don't need to look anymore to the concept of a data set. We just need to look at the collections, need to just look at a long list of collections, and need to look at the shapes the members adhere to, because that will be the most interesting part for doing source selection. For example, this tells a consumer that all members are validated by that shape, street name profile.shackle, and that it will always describe, for example, the RDFS label predicate. Now, if, for example, we would have a Sparkle query like this, which is a linked data query language, Sparkle, you can over here select the street name version, which you just type the street name, and I want the version identifier of that, or the real object identifier of that, and I want to find the label. Well, the street name profile.shackle, well, this one defines that DC terms as version of is always going to be part of all the members that are in this collection. And that's an interesting one, because now if I have this Sparkle query and I just have the metadata of all the data sets in my collection, in my catalog, I can understand that this query is going to be useful to answer with collections that adhere to that shackle shape. So I can do source selection based on that. So the summary so far is describe an LDES event stream as a collection of immutable objects, which requires you sometimes, for example, with the street names thing, to define new version URIs for your things. And also a cool thing is that a tree collection or an LDES event stream can have a tree shape attached to it, which can help a lot for source selection when you're doing that. Okay, on to the cool stuff. So these are just the basics, but now what if a collection would grow too large for one page? That's when we have to fragment somehow. We have to paginate our collection. You could say we're just going to introduce next links. That's interesting. Like you first have your first 10 minutes of observations, then you have a next link to the next 10 minutes of observations, and so on and so forth. That's interesting because, well, you're going to start from one part and then you're going to follow links. And these links over there, that's yeah, something I love. That idea for pagination. Why? Because hypermedia controls, or the general name for hyperlinks, hypermedia controls, also allow you to describe forms, that they really make your API evolvable. Because, for example, if now I decide that this next page link is not sufficient anymore, because, for example, I had a data set in both the Netherlands and Belgium, and I noticed that most organizations from Belgium only download data from Belgium, and most organizations from the Netherlands only download data from the Netherlands, maybe it's more useful that I just split it in two parts. So let's have one part for the Netherlands and one part for Belgium. But if this was my original entry point and I just define another link, not the next page link, but saying, hey, there's another area over there where you can find more useful data, then that might trigger the client to recover. Like a Belgian client might then say, oh, I find a link over here. And if that client is able to understand that all the data of Belgium is now going to be found in that fragment, it's going to maybe always be able to use that URL to start from to answer all their questions, and it's going to be more efficient. So that way you create more evolvable web APIs thanks to hypermedia or thanks to hyperlinks in your data, which are a kind of metadata, you could say, but not really. So I dislike the word metadata. I rather use the word hypermedia controls, but that's not always understood by everyone. But now for this course, I will use hypermedia for further use. So how do we do that in the spec? Well, the step one is letting the consumer know that this page is the first page of the collection, and this is what you do using a tree view. So with a tree view, you attach it to this page, and then you say this page is actually a view of that event stream, and I have a couple of objects that you can start from. Mind that tree view is a really special predicate because it also indicates to a client that all the objects, all the members of the collection can be found through that link. So that if there are further links, that if you descend all the links possible from that page, that you will find that you will be able to fully replicate the event stream that way. Step 2 is describing a relation to another page. So you say this is a tree view. My current page is a tree view on top of that event stream. Well, then you can say this page has a relation to another, and that other page can be found at next page. Now, this relation is just like a next page or next page link. It doesn't really tell the client a lot. For example, what if this next page actually only contained all the data of Belgium and the current page only contained all the data of the Netherlands? That's something that I would want a client to understand. The example that I'm going to give over here is redesigning this relation object towards something more concrete for a time-based link. There we go. So relation 1 is a greater than relation, which means that you have to look at the tree value over here, that all the members of the next page are going to be greater than this value for the property SOSA result time. So this way, if I have a query, I will be able to tell exactly if the next page is going to possibly give me more interesting results or not. So if I'm only interested in results from 2020 and not from 2021, then please don't follow the next page, because it's not going to give you any useful data any longer. Good, and that's the entire tree collection design, the linked data event stream, because tree collection doesn't necessarily contain immutable items. Linked data event streams will extend on the tree collection concept and will say, look, all the members of the tree collection are immutable, and it's able to design a view on top of that. A collection has members. And then in there with the relation, you can say, well, for example, a substring relation, a greater than relation, less than relation, and so on and so forth. Geospatially contains relation, and so on and so forth. There are a couple of relations already defined in the spec itself. This way you can design any tree-like evolvable APIs beyond pagination, and that's of course where the tree got its name from, the tree specification. Because you can design tree-like information architectures. Of course, it may contain cycles, but for the client you will filter them out because you already visited the page, so you will not revisit the page when you encounter it again. So that's why it's called the tree specification. Have a look through the tree specification, w3id.org/tree/specification. It's quite complex to understand, but I think you got the basics by now getting this presentation. The tree relation concept is the most important one, or the most novel one, and the most relevant for linked data event streams to understand. Now there's a big question that's still here. It is, what should be the core fragmentation strategy for a linked data event stream? And I have my opinion. My opinion is that a linked data event stream should mainly focus on replicating the full history and synchronizing the latest changes. So when I designed that web API, I would design it like this. I would have a last page which contains still the events or the members that are getting updated. So this is a not yet complete one. If you don't know when updates will happen, add an E tag. So that way you can do conditional caching. So you will be able to have a client that goes there and says, every 30 seconds I'm going to poll again, for example, to see whether there's an update, but I'm going to send that E tag with it. And okay, it's still the same E tag, so I don't need to fetch or download the body again because it's going to be the same anyway. Or you could also include the max age header, for example, a cache control max age, which then indicates after how many seconds you would have to poll again. Also, PubSub is possible using tree. You could have a tree import stream predicate added to your collection, saying that look, there's a PubSub interface that will from that moment on give you the new events that are available. So an interesting thing over here now also with the history is that you can put the cache control on immutable. Because, well, the objects are immutable, so the pages are also immutable. You never have to fetch them again. So the client can understand that it only needs to refetch one page, and it doesn't have to do anything else for that. It just has to implement HTTP caching semantics. That's it. Other than that, it will just work with a linked data event stream, and replication also becomes a kind of caching. So thanks to that way, you will replicate a linked data event stream, but it will actually work or act as an HTTP cache as well. And if you want to do something totally different, for example, as I said, with you host a data set for Belgium and the Netherlands together, but you always see that people are interested in Belgium and the Netherlands separately. You can of course just host multiple linked data event streams and interlink them with tree semantic. Have a different tree like that. So if you want to replicate, that means that in this example you will need to keep polling 4 pages, but still functionally it will work. Maybe it will not work in the most efficient way as I would have imagined linked data event stream in the first place, but there's choice. You can design anything what you want using the hypermedia links that are provided, and it will work. So the priority shield for data publishing, it helps you decide what should be done by you and what can be done by others. So also these fragmentations, and they can be from the linked data event stream. Others can provide other fragmentations on top of it. That's interesting, but also don't be too dogmatic about it. Don't only focus on replication and synchronization when you actually also already want to do more with your data set. For example, if I would want to have OpenStreetMap as a linked data event stream, I probably also would include some geospatial fragmentation already in the core, because otherwise, if everyone always has to replicate entire OpenStreetMap before being able to show a map of their own country, that's going to be a really tedious task. So I think that geospatial index would be really, really, really useful over there. 2 questions left. The first question is, what if I want to change the shape of the members? So what if I already have a collection, a tree collection or a linked data event stream in production, and after a while, after a year or two, I want to change some properties because they're out of fashion, and I want to introduce new, more modern properties for describing my things. Maybe even splitting to a property into two properties instead. I want to do something like that. Well, there are two choices, and I think one is to try to keep all the shape backwards compatible. In that sense, if your shape is backwards compatible, like only adding another property, a required property to your shape, then you can just create new version objects of all the entities and add them again at the linked data event stream, and just keep using the same event stream in that way. If your shape is not backwards compatible, I would say that you have a new linked data event stream that way. So it's not the same event stream anymore if the shape is not backwards compatible. And of course, you're using hypermedia, you're using DCAT descriptions, so you can update the DCAT description towards the new linked data event stream, towards the new views that now work on top of that one, and you can still keep the old one up and running if you just create an adapter, just make sure that you have an HTTP thing that from the moment that you do a request there, that it then fetches the new one, but you also still expose the old one in a legacy API. So I think it's really important now to make sure to think carefully about your collection design and what shapes you expose. It is evolvable to a certain extent, but it's the most fragile thing to touch in a linked data event stream. While with other web APIs, I think almost everything may break. Over here we have a way looser contract between clients and servers, but a really important contract is will always remain the shape, because that really identifies what the event stream is. It's really the identity of the event stream. 2, what if my backend does not keep the entire history and I still want to put a linked data event stream on top of that? Well, that's why something like this, that's possible. We allow that, but you have to be really transparent about it. So if you remove your things from your own disk, that's possible. You can remove data from your own disk without the actual semantics of the event stream object changing. You can still say, well, that object that disappeared over here, it is still part of it, but I don't have it on my own disk. So if you would HTTP request that thing, you would get a 404, but a 404 means I didn't find it on my machine, but maybe there's someone else who archived it and who can still say and correctly say that it's part of that linked data event stream. So that's possible, and that's why you have to define a retention policy. You have 2 ways of defining a retention policy. One is based on time. For example, you can say that there's a linked data event stream. It has a certain view. This is really important, that the retention policy applies on a view, not on the event stream itself. So it's the view or the server implementation that says, oh, I don't keep all the data in this event stream. And then this policy is a duration ago policy, again with the 3 paths to select that I have to look at generated at time, and that the generated at time that is older than 1 year, that data can disappear from the server. A second way of doing a retention policy is based on the amount of objects. So you can define, again, a retention policy P1 over here. That is a latest version subset. You define the amount that you want to keep, and also the version key. For example, is version of. If you define that one, it will follow the is version of, will group all the objects by is version of, and then we'll keep the 2 last ones over there. That's it. That's the entire idea about linked data event streams on a technical level. If you want to follow our developments, check out tree.linkeddatafragments.org, and I want to certainly thank our funder, that's the Semantic Interoperability Community, or SEMIC. Thank you very much.